Assalamualaikum and hello everyone. My name is Nurul Shafika binti Amran. Welcome to our video presentation on crude palm oil, one of the most widely used edible oils in the world today. First, what exactly is crude palm oil? Crude palm oil is the part of liquid in palm oil made through a process called fractionation. It contains a saturated fatty acid like oleic acid and palmitic acid and is rich in antioxidant. Blending palm oil such as canola that improve stability and sensory qualities. Other mixtures such as does containing 30 to 40% palm oil provide increased frying performance and minimize polymer formation. Thanks to natural antioxidant in palm oil, is more healthier and stable when using in cooking. It helps the possibility of frying induced formation of hazardous when frying for a long time. Lastly, the oil is widely used in food industry for frying snacks, cooking oil and making shortening. It helps the flavor of the fried food throughout and is also more affordable compared to other pure oils.
I'm Nuradiana binti Matsman. Let's look at the production process of RBD palm oil. It begins with fresh fruit bunches from oil palm trees. To make the oil suitable for consumption, it goes through refining, bleaching and deodorization, also known as RBD. R means refine, to remove impurities and free fatty acids. B is bleach, to remove color pigments. D stands for deodorize, to remove unwanted smells. This gives us RBD palm oil, a clear and stable oil. Next, RBD palm oil goes through a fractionation process where it is cooled and separated into two parts, which is RBD palm oil, the liquid portion used in cooking and frying, and palm stearin, the solid portion used in production like margarine and shortening. Now, let's take a closer look at how RBD palm oil is produced from raw palm oil. RBD stands for refined, bleached and deodorized, and it refers to a high-quality golden liquid oil that results from several key processes. Step 1. Crude palm oil extraction. The process begins with fresh fruit bunches from the oil palm. These bunches are sterilized, striped and pressed to extract crude palm oil. At this point, the oil contains many impurities such as phospholipids, free fatty acids, and color pigments and odorous compounds. Step 2. Refining process. To convert crude palm oil into edible oil, we perform several refining processes. First, degumming. This removes phospholipids, also known as gums. Neutralization. Free fatty acids are removed by reacting them with an alkali like sodium hydroxide, performing soap stop. Bleaching. Color pigments like carotenoids are removed using bleaching earth or clay under vacuum. Deodorization. Finally, the oil is treated with high temperature steam under vacuum to remove unpleasant odors. After this, we get RBD palm oil, clear, neutral in smell and taste, and safe for consumption. Step 3. Fractionation process. To remove RBD palm oil, the oil undergoes fractionation, a physical modification process. First, the RBD palm oil is cooled slowly and carefully. As it cools, the oil begins to crystallize, separating into liquids and solid parts based on melting point. Then, filtration is used to remove solid portion, known as palm stearin. What remains in the final product? RBD palm oil, the clear golden liquid commonly used in cooking oil. deep frying, and food processing.
Study is grounded in the principle of the blending oil with different fatty acids profiles can enhance their overall functionality. For example, which in palm olein, rich in saturated fats and oxidant like toothperol, was blended with canola oil, which is high in unsaturated fats. This combination aims to balance oxidative stability, texture, and nutritional content. So during the frying, oils undergo thermal degradation. So oxidation leads to the formation of the primary product such as a peroxide and secondary products such as aldehyde and ketone. And then it also have a hydrolysis that occur because to provide the presence of the water leading to the free fatty acid. So when oils are heated for long periods at high temperature, for example, in the study is at 180 degrees Celsius for 60 hours. So the polymer compounds start forming. So this large molecule degrade oil quality and are indicator or all extensive use or overheating. So gas chromatography was used in identify the fatty acids present in the blends. So the goal was to find the right balance between the saturated and unsaturated fatty acid, helping to create a product that is not only suitable for frying but also healthier for consumer. For the method, it uses a physicochemical test. Okay, first a cold test. It used to check the low temperature stability and color, check the specific gravity and refractive index using a seismometer and refractometer, viscosity, and they also check the iodine value for the unsaturation level. So all samples were heated in electric fryer for 60 hours. So the sample periodically taken for analysis. Ransiment tests were conducted to measure the oxidative stability. So the longer the induction period, the more resistant the oil is to oxidation. So polymer content was measured using gravimetric or chromatographic technique. So additionally, sensory evaluation were done with a trained panel who test potato chip fries in the different blends, rating them on a flavor and a texture using a 5-point hedonic scale. So I think the blend palm olein with canola oil effectively improved the stability, nutritional value, and safety of the frying oil.
Palm olein contains about 34.3% palmitic acid, which is a saturated fat. It is a very stable under heat because their chemical structure has no double bond, making them less likely to break down during frying. It also contains around 44.1% oleic acid, which is a monounsaturated fat. Oleic acid is more stable than polyunsaturated fat and help improve the oil resistance to oxidation. On the other hand, canola oil has only 4.6% palmitic acid and a much higher level of linolenic acid, about 9.6%, which is a polyunsaturated fat. This type of fat are highly prone to oxidation and break down faster when exposed to heat. Next is induction period, used to measure the oxidative stability. In this study, the oil was tested at 100 degrees Celsius and the time for oxidation to start was recorded. The results show that palm olein has the longest induction period at 34.2 hours. In comparison, canola oil only lasts 15.7 hours before it starts breaking down. As the percentage of palm olein in the blend increases, the induction periods get longer. This proves that palm olein have improved heat stability. Next is Totox value of palm olein, canola oil and their blend. Totox stands for total oxidation value. Palm olein has the lowest Totox value at 11.5, while canola oil has a higher value of 22, meaning it is more oxidized and less stable during frying. As for blend oil, more palm olein in the blend has lower Totox value. For example, the 70% palm olein blend has a Totox of 30.3, while the 25% palm olein blend rises to 80.9.
Palm oil has high oxidative stability because it rich in both saturated fat, which is palmitic acid, and monounsaturated fat, which is oleic acid, to help resist oxidation. It also contains tocopherol and tocotrienol, which is a natural vitamin E compound that acts as antioxidant and reduce breakdown during frying. All of these compounds help maintain the original flavor of the food without producing rancid or burnt smell. In addition, palm oil has a rich orange-yellow color due to natural carotenoid. They also are less likely to form harmful oxidation products like peroxide, polymer, or rancid compound. That's why blending with palm oil can improve color, flavor, and frying life. Based on its property, crude palm oil has several useful applications. First, it is widely used as a deep frying oil, especially in the preparation of snack chips and fast food, since it has higher stability and resistance to heat, which make it last longer during repeated frying sessions. Second, it is often blended with less stable oil like canola or sunflower oil to improve shelf life and flavor performance. Third, palm oil is also used in margarine production, baked goods, and processed food, where all texture and stability matter. The stability of heat also makes it useful in industrial frying system and even in the bio-based products sector.
Hi, my name is Nur Fahisha. For the last part is sustainable. Palm oil is staple in global food and cosmetic industry, but it is environmental footprint, especially due to deforestation and habitat loss. Grow concern to address these responsibility sources like RSPO certified palm oil is important. So in this study, we demonstrate that blending RBT palm oil with canola oil enhance the functionality and stability. That means less oil goes to waste, and there's no relying 100% palm-based oil formulations support to more sustainable model. Next, about green chemistry standpoint, this blend help reduce the food waste because they are more stable and degradable less during the storage and frying. Also, the higher content of natural unsaturated fat means manufacturer can reduce that using the hydrogenation fats, which are less health and require more chemical processing. This aligns with sustainable goals, not just environmental but also in public health. So for the conclusion we can make from this article, blending palm oil with canola oil show in the study is valuable step towards more sustainable and functional oil usage to improve the shelf life, nutritional quality, and can reduce environmental pressure by lowering the reliance on single sources palm oil. This is a strong example on how science and sustainability can work together in the food innovations.